We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that. Throughout human history, the quest to understand the nature of reality has been a defining pursuit of science, philosophy, and spirituality. What is the universe made of? How do the laws of physics govern it? And the most profound question of all, does reality exist as we perceive it, or is it a mere construct of our minds? Recently, a revolutionary development in quantum computing has reignited these questions. Scientists have created a new quantum chip so advanced that it has shaken the very foundations of our understanding of reality. The implications of this discovery are nothing short of paradigm shifting. According to the data generated by this quantum chip, the universe as we know it may not actually exist. Let's start with the basics. Quantum mechanics is the branch of physics that deals with the behavior of particles at the smallest scales, atoms and subatomic particles. At these scales, the rules of classical physics, the ones that describe the motion of planets, cars, or even a thrown baseball, no longer apply. Instead, particles seem to exist in multiple states at once, a phenomenon known as superposition. They can also affect each other instantaneously over vast distances, a phenomenon called entanglement. These strange behaviors have long puzzled scientists and challenged our understanding of what it means for something to exist. The creation of this new quantum chip has taken our understanding of these phenomena to a whole new level. Designed to operate at unprecedented speeds and handle vastly more qubits than previous models, this chip has allowed scientists to simulate quantum systems with a precision never before possible. The results of these simulations have led to a startling conclusion: the universe may not have a physical foundation. To understand why, we need to delve into one of the most debated interpretations of quantum mechanics, the idea that reality is observer-dependent. This stems from the famous double-slit experiment. When particles like electrons are shot at a barrier with two slits, they behave like waves, creating an interference pattern on a screen behind the barrier. But here's the strange part. If you place a detector at the slits to observe which slit each particle passes through, the interference pattern disappears. The particles start behaving like particles again, as though the very act of observation determines their behavior. This has led to the unsettling conclusion that particles don't have definite properties until they are observed. Instead, they exist in a state of probability, a mathematical description of all the possible states they could be in. It's as if reality itself doesn't solidify until a conscious observer looks at it. Now, let's connect this to the breakthrough in quantum computing. The new quantum chip has enabled scientists to run simulations of quantum systems on an unprecedented scale. One of the key experiments involved simulating the behavior of particles in a universe governed purely by quantum mechanics. The results were astonishing. The simulation suggested that particles only exhibit classical physical properties when observed by an external system. In other words, the universe as we experience it, solid, physical, and governed by deterministic laws, may be nothing more than a construct that emerges when we observe it. Without observation, the universe exists as a mathematical abstraction, a cloud of probabilities with no definitive reality. This aligns with the philosophical concept of non-realism, which posits that the physical world is not objectively real. Instead, it's a kind of shared illusion created by our consciousness interacting with the underlying quantum fabric of reality. This idea has profound implications for how we understand existence. If reality is not objectively real, then what does it mean to say that something exists? To answer this question, we must confront the nature of consciousness itself. For centuries, scientists and philosophers have debated the relationship between mind and matter. Is consciousness a product of the brain, or is it something more fundamental, a fundamental aspect of the universe itself? The data from the quantum chip suggests the latter. The simulations revealed a strange phenomenon. In a universe without conscious observers, the quantum systems never collapsed into a definitive state. They remained in a superposition, a kind of limbo where all possibilities coexisted. This strongly implies that consciousness is not just an emergent property of physical systems like the brain. Instead, it seems to play a fundamental role in shaping reality itself. Some physicists have taken this a step further, proposing that consciousness may be the only thing that truly exists. This is reminiscent of the ancient philosophical concept of idealism, which holds that reality is fundamentally mental rather than physical. From this perspective, The universe is not a physical place where events happen independently of observers. Instead, it's a kind of shared dream, a mental construct created by the interplay of countless conscious minds. This idea may sound far-fetched, but it is supported by some of the most puzzling phenomena in quantum mechanics. For example, quantum entanglement shows that particles can influence each other instantaneously, even when separated by vast distances. This has led some scientists to propose that the universe is fundamentally interconnected, with all particles existing as part of a single, unified whole. The new quantum chip has provided further evidence for this interconnectedness. By simulating the behavior of entangled particles on a massive scale, scientists found that the connections between particles were not limited by space or time. This suggests that the universe is not a collection of separate objects interacting through physical forces. Instead, it's a seamless web of relationships, where the distinction between here and there or now and then breaks down. If this is true, then our everyday experience of reality is a kind of illusion. The objects we see, the spaces we inhabit, and even the passage of time are all constructs that emerge from the underlying quantum fabric of the universe. This doesn't mean that reality is fake or unimportant, far from it. But it does mean that reality is far stranger and more complex than we ever imagined. Once believed, if the future can influence the past, then our linear understanding of time is merely a construct, a convenient illusion that helps us navigate the macroscopic world. At the quantum level, time is not an arrow but a web with connections spanning both directions. The implications of this discovery are profound. If time is not linear, then our understanding of history, memory, and even free will must be reconsidered. Could events in the present be shaped by choices we have yet to make? Could our consciousness, untethered from the constraints of linear time, perceive glimpses of the future? These questions are not merely theoretical. They are grounded in experimental data generated by the quantum chip. Researchers have begun exploring the possibility of quantum time travel, not in the sense of physically traveling through time, but in the sense of sending information backward or forward through the quantum fabric. Such technologies, if realized, could revolutionize fields ranging from communication to decision-making. But with these possibilities come profound ethical dilemmas. If we can influence the past or glimpse the future, how do we ensure that such power is used responsibly? How do we navigate the risks of altering timelines or creating paradoxes? And how do we reconcile the knowledge that time, as we experience it, is an illusion? The quantum chip also challenges our understanding of space. In classical physics, space is a vast, empty stage where events unfold, a neutral backdrop for the drama of the universe. But quantum mechanics tells a different story. At the quantum level, space is not empty. It is a seething cauldron of energy filled with virtual particles that blink in and out of existence. This quantum vacuum is not just a curiosity, it is the foundation of reality itself. The new quantum chip has allowed scientists to probe this vacuum with unprecedented precision, revealing its dynamic, ever-changing nature. The simulations suggest that space is not a passive container, but an active participant in the unfolding of the universe. One of the most startling findings involves the concept of quantum foam. At the smallest scales, space appears to be a frothy, bubbling landscape where the distinctions between here and there, or even existence and non-existence, break down. This quantum foam is thought to give rise to the fundamental forces and particles of the universe, shaping everything we see and experience. But the quantum chip simulations go even further, suggesting that this foam is not confined to our universe. Instead, it may connect to other universes, forming a vast, interconnected multiverse. These connections, known as quantum tunnels, could allow particles, information, or even energy to flow between universes, creating a cosmic web of possibilities. This idea aligns with the theory of the multiverse, which proposes that our universe is just one of countless others, each with its own laws of physics and constants of nature. The quantum chip provides new evidence for this theory, suggesting that the multiverse is not just a theoretical construct but a tangible reality. If this is true, then our universe is not an isolated island but a single thread in a vast cosmic tapestry. The implications are staggering. Could life exist in these other universes? Could we someday communicate with them or even travel between them? And what does this mean for our understanding of existence? The quantum chip's revelations also challenge the concept of materialism, the idea that the physical world is the only reality. For centuries, materialism has been the foundation of science, guiding our understanding of everything from atoms to galaxies. But the data generated by the quantum chip suggests that reality is not fundamentally physical. Instead, it appears to be informational. At the quantum level, particles do not exist as solid objects. They exist as probabilities, mathematical descriptions of all the possible states they could be in. This suggests that the universe is not a physical structure but a computational one, governed by the rules of quantum information theory. From this perspective, the universe is more like a computer simulation than a physical machine. Its fundamental components are not particles but bits of information processed and transmitted through the quantum fabric of reality. This idea, known as the quantum information paradigm, is revolutionizing our understanding of physics, biology, and even consciousness. One of the most intriguing implications of this paradigm is the possibility that the universe itself is a kind of quantum computer. If reality is informational, then the laws of physics are the algorithms that govern its operation. The new quantum chip, with its unprecedented computational power, is beginning to unlock these algorithms, revealing the hidden logic of the cosmos. But this raises a profound question. Who or what programmed the universe? If the universe is a simulation, then it must have a creator, a cosmic programmer who designed its rules and parameters. This idea, known as the simulation hypothesis, has sparked intense debate among scientists, philosophers, and theologians. Some argue that the simulation hypothesis is a modern version of the concept of God, reframed in the language of technology. Others see it as a testable scientific theory, with the quantum chip providing the tools to search for evidence of the universe's programmed nature. Still, others caution against jumping to conclusions, emphasizing that the simulation hypothesis is just one of many interpretations of the data. Regardless of its validity, the simulation hypothesis forces us to confront fundamental questions about existence. If the universe is a simulation, what does that mean for our place in it? Are we mere characters in a cosmic program, or do we have the power to shape our destinies? And if the simulation can be understood, can it also be altered or even hacked? These questions are not just philosophical, they have practical implications for the future of science and technology. The quantum chip, by simulating quantum systems at an unprecedented scale, is beginning to uncover the hidden rules of the universe. These rules could enable us to manipulate reality in ways that were once thought impossible, from creating new forms of matter to altering the flow of time. But with these possibilities come risks. The power to manipulate reality is a double-edged sword, capable of both incredible creation and catastrophic destruction. As we venture further into the quantum realm, we must grapple with the ethical and existential challenges posed by this new understanding of reality. The quantum chip is not just a scientific breakthrough, it is a mirror reflecting the deepest questions of human existence. It challenges us to rethink our assumptions, expand our horizons, and confront the mysteries of the universe with curiosity and humility. It reminds us that science is not just about discovering facts, but about exploring the unknown, driven by the same wonder and imagination that have inspired us since the dawn of time. As we stand on the brink of this new quantum frontier, one thing is clear: the journey has just begun. The discoveries we make in the coming years will not only reshape our understanding of reality, but also redefine what it means to be human, opening up new possibilities for exploration, creativity, and connection. Let us embrace this journey with open minds and open hearts, knowing that the quest to understand reality is not just a scientific endeavor, it is a profoundly human one, rooted in the same curiosity and wonder that have driven us to explore the stars, unravel the mysteries of life, and seek our place in the cosmos. The quantum chip is not just a tool for understanding the universe, it is a window into the infinite, a reminder that the greatest discoveries lie not in the answers we find, but in the questions we ask, and in the vast, interconnected web of existence. We are all participants in the unfolding story of the cosmos, shaping reality with every choice, every thought, and every act of observation.